So let's talk about multiplying mixed numbers. So we've learned how to multiply fraction times a whole number. We've learned how to multiply fraction by a fraction. So what we need to do is talk about multiplying mixed numbers together. There is the temptation to just say, well, when I add mixed numbers, I take and add the mixed number part, or I add the whole numbers and I add the fractions. So why don't I do the same? Why don't I just multiply the whole number parts and multiply the fraction parts and get the answer? And that doesn't work. And let me just give you a little quick sketch here. So let's say we had something that was 5.5 by 6 1/4. And I'm going to try and draw this quickly as best as I can. So this is 1, 2, 3, 4, 5, and then we'll make this a half right here. Okay, so here's 5 complete rows and a half right here. And let's do 6 1/4. So 1, 2, 3, 4, 5, 6 1/4. I did way too much there. All right, so you already know that area is length times width, right? So if we were to do just 5 times 6, again, this is the way that a lot of people guess that it should be. It should be 5 times 6 and 1/2 times 1/4. Again, this would be the 5, and this would be the 6. Let me push this up a little bit so it's not in our way. And 5 times 6 would give us the area of this part right here. Right, and then this is 1/2 right here, and this is 1/4 right here. So if we did 1/2 times 1/4, it would give us the area of just this square. Remember, length times width right here. So if we just did 5 times 6, we'd get the area of this part. Right, again, I'm imagining this as a rectangle because when we multiply length times width of a rectangle, that gives us area. So this is a nice way to represent it. And again, remember when we first started learning about multiplying fractions, we did it as an area model. So this 5 times 6 would give us the area of just this part of the rectangle. And 1/2 times 1/4 would give us just this part. That would mean that we would not be counting this part right here. All right, we would overlook them. All right, so in spite of the fact that it's tempting to do 5 times 6 and 1/2 times 1/4, we lose out a lot of the area if we do that. All right, so we can't just do whole number times whole number and fraction times fraction. We have to, actually, if we wanted to do this, we would have to do 5 times 6, and then we would have to do, this part would be 1/2 and this would be 6, so we'd have to do 1/2 times 6, and then we would have to do 5 1/4, so 5 times 1/4, and 1/2 times 1/4. That would work, right? Because that would account for all the squares that are in here, or all the little rectangular pieces, but it would be a mess, all right? So while this would work, we don't want to do that, all right? So let's go back and we're going to look at another method that's a little bit easier than that, right? Now, I want to bring in the sheet that you did for homework yesterday, or you were supposed to do for homework. If you remember this sheet where it was just multiply the pairs of numbers and you were supposed to simplify it before multiplying. And I want to draw your attention to this last row, 17, 18, 19, and 20. And I'm not sure if you paid attention to this when you were doing it or if you just multiplied, but in every one of these cases, there is an improper fraction in the product. Actually, not in this one. 17, 18, and 19. There's an improper fraction in each of those. And my guess is you didn't even bat an eye when you did it. You probably just went and multiplied because it was a fraction times a fraction. That is the strategy that we're going to use. If we can just make our two numbers, let's go back to the sheet that you're supposed to be doing today. If we can make these just a single fraction by turning them into an improper fraction, we can just use the regular multiplication algorithm. And that's what we're going to do. We're going to take 6 times 2 is 12. 12 plus 5 is 17. we're going to say this is 17/6 times, and then we're going to convert this into an improper fraction. 3 times 3 is 9, plus 1 is 10, 10/3. And then we're going to multiply. First, I'm going to look to see if there's anything in common I can cancel out. 17 and 3 are both prime, so no. But 6 and 10 are both even, so they'll have a common factor of 2. So 6 divided by 2 is 3, 10 divided by 2 is 5. I check up and down to make sure that there are no common factors. 5 and 3 are both prime, so no common factors there. 17 and 3 are both prime, so no common factors there. So I'm going to multiply across. 3 times 3 is 9 in the denominator. 17 times 5, I don't know that one off the top of my head. That's 5, that's 85. All right, so 85/9. All right, now I'm going to take this improper fraction and convert it back into a mixed number. So how many times does 9 go into 85? It goes in 9 times with a remainder of 4. So this is 9 4/9. All right, again, we could do that really long way I just showed you, where we do 2 times 3 and 5 6 times 1/3 and 2 times 1/3 and 3 times 5 6, but this is much faster. We just convert our mixed number into an improper fraction, mixed number to an improper fraction, and then multiply. All right, let's take a look at number 2. All right, so we're going to convert this into an improper fraction. That's 3 times 1 is 3, plus 2 is 5, so 5/3. Times 9 times 4 is 36, plus 5 is 41, so 41/9. We're going to look along the diagonals here. Hopefully you're realizing there's nothing in common. 3 and 41 are both primes, 9 and 5 are both primes, so there's nothing that they'll have in common, so let's just multiply. 3 times 9 is 27. 5 times 41 is 205. This is not going to be that nice. Let's see. 27 into 205. That's almost 30. So I'm going to say, how many times does 3 go into 20? That would go in 6 times. So let's guess 6 here, but it might be 7. 6 times 7 is 42. Put down the 2, carry the 4. 6 times 2 is 12, plus that 4 that I just carried is 16. Yeah, we could have gone 7 times. So let's do it again. 7 times 7 is 49. Put down the 9, carry the 4. 7 times 2 is 14. Plus 4 more is 18. All right, so we're going to subtract. 15 minus 9 is 6. And 19 minus 8 is 1. So we get 16 holes. Sorry, 7 holes. Oh my goodness. 7 holes and a remainder of 16. So this is 7 and 16/27. Okay, let's try one more, and then I want you to do this one on your own. So pause the video and I want you to try this. So again, you're going to convert the mixed numbers into improper fractions. See if you can cancel along the diagonal or up and down. And then once you finish that, multiply across and then turn your improper fraction answer into a mixed number. And then come back when you're done. Okay, let's do that. That's 14, 15, 16, 17 sevenths times, this is 9 fifths. 17 and 5, both prime. 7 and 9 don't share any common factors. So let's just multiply across. 7 times 5 is 35. 9 times 17. 9 times 7 is 63. 9 times, so that's 153. 35ths. All right, now we're going to do 35 into 153. Again, 3 would go into 15 5 times, but 35, that's higher than 30. So I'm just going to go with 4 times. See if that works. 4 times 5 is 20. Put down the 0, carry the 2. 4 times 3 is 12, plus the 2 that we carried is 14. 3 minus 0 is 3. 5 minus 4 is 1. So we got 4 whole groups of 35 with a remainder of 13, so it's 13 35ths. How'd you do on that one? Hopefully you did well. All right, let's try one more together, and then I'm going to ask you to go ahead and work on this. All right, 6 times 5 is, actually, sorry, I'm going to ask you to do this one, and you're going to work on it, and then pause while you pause the video, and then come back and check to see how you did. All right, so don't cheat and just watch me do it. Make sure you pause and do it yourself. Okay. Now that you're back, 6 times 5 is 30, plus 1 is 31, 31/6 times 3/4. Notice that we just had a regular proper fraction here. We didn't have to do anything to it. Okay, before we multiply across, let's look to see if we can cancel. So here, 31 and 4, no, that's prime, so 4 won't go into it. Here, 3 does go into both 6 and 3. 3 goes into 3 once, and it goes into 6 twice. All right, so we're going to multiply across. 31 times 1 is 31. 2 times 4 is 8. All right, if you didn't do that, you would have got 93 over 24, which is going to be harder to simplify, but hopefully you were able to do that if you forgot to cancel first. All right, so then 31/8, let's see, 8 goes into 31 3 times, because 3 times 4 would be 32, that's too big. So 3 times 3 is 24, and then it would have a remainder of 7. So 3 and 7/8. Again, I just did that in my head. If you don't like that, you can always do 31 divided by 8 and do 3 times. And then you could do short division and get remainder 7, or you could do long division. I don't have room here. But either way, you would get 3 whole things and then 7 as the remainder, so 7/8. Okay, hopefully you're all right. With these, again, the only additional step is changing it into an improper fraction and then just multiplying, canceling and multiplying, and then changing it back into a mixed number. All right, so here are our 4 answers, and then you're going to finish these 12 problems. Okay, good luck. Use the answer key to check your work, and then if you have any questions, make sure you send me an email or a text or something. All right, bye.